Hello students, today we have discussed the class 12 chapter solution. In this, the class 12 chapter having a topic osmosis, or we can say osmotic pressure. So today we have discussed the next topic, that is called osmotic pressure. Osmotic pressure. Osmotic pressure, and it is denoted by a symbol capital pi. This is the fourth colligative properties of solution, that is the osmotic pressure. Before we discuss about the osmotic pressure, first of all we learn the what is osmosis. So all you know that what is osmosis. If you know the term osmosis, then before the learning of the topic osmotic pressure, we first of all know about the osmosis. And when we know the meaning of osmosis, before that we have discussed the next term, the very important term, that is called diffusion. Before learning the topic, the osmosis, there is a term that is called diffusion. So what do you mean by the term diffusion? Diffusion means the movement of particle from their higher concentration to their lower concentration. The movement of particle from their higher concentration to their lower concentration. So before we discuss the topic in an everyday life, that what is diffusion, the diffusion, you take an example like if a food is cooking at your home and the smell of the food is goes outside, and somebody asks you that you have your mother prepare chola bhatura or something like sahi paneer. So what they can smell, what they can found that they in the house they have prepared for chola bhatura. So because the movement of particles of chola bhatura, the movement of particles which is present at the particular area is higher. Basically we can say the concentration of the particle at that particular area is higher as compared to the other area of the house. So what will happen? The movement of particle from their higher concentration to their lower concentration. The movement of particle from their higher concentration to their lower concentration. Or we get an everyday life example like incense stick. That is also when there is a incense stick is burning, then the smell of the incense stick is move all around the house. So what will happen? There is the movement of particle at that particular condition, that the movement of particle is higher at that particular area to the movement of the particle where a lesser concentration. So we can say that the diffusion means the movement of particle from their higher concentration to their lower concentration. You got my point? So movement of particle is from higher concentration to their lower concentration. Now we have discussed the very important term, that is called osmosis. Osmosis. What do you mean by the term osmosis? If you know the term, if you distinguish the term that diffusion, then the osmosis is the reverse of diffusion. Osmosis is reverse of diffusion. That means the movement of particle. That means the movement of particle from their lower concentration of solution to their higher concentration. And we add one important term, the movement of particle from their lower concentration of solution to their higher concentration of solution through a semi-permeable membrane. That is called osmosis. And you learn the important term, that is called semi-permeable membrane. Semi means half, permeable means permission. These are the membrane which provide the permission for the movement of particle. That is called SPM. Permission. That is called SPM. or we can say that there is a many SPM, and these membrane it can be animal membrane as well as vegetable membrane. In animal membrane, there is called pig bladder, or we can say goat bladder, parchment paper, etc. These are the synthetic membrane, and there is also a natural membrane. We have taken an example like cellophane. Sorry, these are the synthetic membrane, that is called cellophane. These all are natural membrane. So what do you mean by the term osmosis? Osmosis means the movement of particle from their lower concentration to their higher concentration through a semi-permeable membrane, that is known as osmosis. Okay, beta. Before we discuss these two important terms, that we have to learn the most important part, that is called osmotic pressure. So you know that the movement of particle from the lower concentration to their higher concentration through a semi-permeable membrane. Now we have discussed with the help of a diagram. What is osmosis? What is osmosis? So you learn the term osmosis. Osmosis means the movement of particle from their lower concentration to their higher concentration of the solution through a semi-permeable membrane, that is known as osmosis. Now from the diagram we have discussed what is osmosis. What is osmosis? We have taken a two chamber in which we have put a membrane which having a very small holes, okay beta, that is known as SPM, semi permeable membrane, SPM. Out of this we have taken a two solution. Here we have taken a solution whose concentration is C1, and there is another chamber, that is a solution whose concentration is C2. So there is a something movement of particles. There is a concentration solution C2 and there is a concentration solution C1. So there is a possibility that the movement of particles. So where we have taken that we have to know that C1 is greater than C2. The concentration of C1 is greater than the C2. So here the solution, the movement of the concentration of solution C1 is greater than the solution C2. So what will happen? Now we have taken, there is a two important terms in a solution, that is solute and a solvent. That is a solute and a solvent. Here is a solute. We have taken a, here is a solute. Here we have taken a solvent. Solute. What is solute? What is solute? The component which are present in a smaller amount in the solution is called solute, and the component which are present in large amount within the solution is known as solvent. Now what is this? The solute, the size of the particles. The size of a particle is large. Here the size of the particle is small. So we can say that the movement of particle is from both the side. If we apply the two chamber and we have a that is a membrane, then there is a movement of particles. Movement of particles have a two possibility. The movement of particle is from solvent to solute, or we can say that movement of particle is from solution to from solute to solvent. So which process is done? We know that the movement of solute, the particle size is very large. they having very small pores. So what will happen? The movement of particle from the solution to solvent is possible or not? That is not possible, because the size of the particle of solute particle is large. So that why that the movement of particles from solute to solvent is not possible. But what happened? The movement of particle from solute to solvent, the movement of particle from solute to solvent, solvent to solute is possible. So according to the definition of osmosis, we know that the movement of particle from their lower concentration of the solution to their higher concentration. So what is osmosis? The movement of particle from their lower concentration of solution to their higher concentration of solution through SPM, that is called semi-permeable membrane. So the movement of particle, here we know that the concentration of C1 is greater and that is C2. So the movement of particles from their lower concentration, here C2 is lower. Beta, listen, the C2 is lower. So what will happen? The movement of particle from their lower concentration of solution to their higher concentration of the solution through a SPM, that is known as osmosis. Clear to all? Now we have discussed in terms of solvent. In terms of solvent, there is another definition of osmosis in which the movement of particle from their higher concentration of solvent to their lower concentration of solvent through SPM. The movement of particle from their higher concentration of solvent to their lower concentration of solvent through a semi-permeable membrane, that is known as osmosis. Here the concentration of solvent is higher. So the movement of the particle where the concentration of the solvent is higher to the particle where the concentration of solvent is lower. So the movement of particle from their higher concentration of solvent to a lower concentration of solvent through a semi-permeable membrane, that is known as osmosis. So before we have discussed these terms, osmosis and the diffusion, the part which we have discussed, that is the osmotic pressure. So you know what is osmosis. Now we have discussed osmotic pressure. We have discussed osmotic pressure. We have already discussed osmosis and osmotic pressure. Now the osmotic pressure that is denoted by a symbol pi. So what is osmosis? Again we have taken in a chamber and there is a two chamber. Here there is a semi-permeable membrane which having a very small pores. So what will happen? What will happen? What is that? The movement is possible from their higher concentration to there. The pressure required to stop the osmosis, because the osmosis occur up to the equilibrium is achieved. So the process is attained spontaneously. Now the pressure which is required to stop osmosis, the pressure which is required to only stop the osmosis, that is known as osmotic pressure. The pressure which required to stop the osmosis, yeah, we can say that the pressure which required to stop the movement of particle from their higher concentration of the solvent to their lower concentration of the solvent through a semi-permeable membrane, that is known as osmosis, osmotic pressure, the pressure which is required. Now, what is the, from the experiment we can say that the osmotic pressure is directly proportional to the concentration. Now again, the osmotic pressure is directly proportional to the temperature which we have taken in a Kelvin. So we have combined these two equations, that is pi is directly proportional to Ct. We have to eliminate the proportionality sign. Then what will happen? There is another one constant that is called gas constant, that is RCT. So we have combined these equations, so that is a CRT. So pi is equals to CRT. Pi is the osmotic pressure, C is the concentration, R is the gas constant, and T is the temperature. So what is the value of R? The value of R is 0.0821 liter atm per Kelvin per mole. And if there is another, if the pressure is in atm, so you have to apply the value of R. If the pressure is in bar, so 0.083 liter bar per Kelvin and per mole, and you have to apply the temperature which is in degree Celsius. Now there is another formula in terms of mole. So pi is equals to this is a concentration. What is concentration? Or we can say that it is a molarity. So what do you define the molarity? The number of moles of solute dissolved in a per liter of solution. So we have take pi is equals to NYV, number of moles of solute dissolved in a volume of solution in liter, that is R and T. So that is a formula for osmotic pressure, to calculate the osmotic pressure. Now we have wind up the lecture, that is, first of all we have discussed what is diffusion. So what do you know about the term diffusion? The diffusion means the movement of particle from their higher concentration to their lower concentration. But in terms of solution, we have discussed the definition of osmosis. So what will happen? The osmosis is the reverse of diffusion. So what is osmosis? The osmosis in terms of solution, that the movement of particle from their higher concentration to their lower concentration through a semi-permeable membrane, that is known as osmosis. Or in terms of solvent, the movement of particle from their higher concentration of solvent to their lower concentration of solvent through a SPM, that is known as osmosis. Now what is osmotic pressure? So osmotic pressure is the pressure which is required to stop the osmosis. The pressure which is required to stop the osmosis, that is known as osmotic pressure. It is denoted by a symbol pi, and they having a formula pi is equals to CRT. Here pi is the osmotic pressure, C is the concentration, R is the temperature, R is the gas constant, and T is the temperature. In terms of molarity or in terms of number of moles, we have to write the formula that pi is equals to N by B RT. Okay, thank you to all.